Question number 7. Question number 7 is y is equal to x minus 2 divided by mod of x square plus x plus 1, mod of x square plus x plus 1. Okay. So again we are getting a modulus operation, and this time it is appearing in the denominator. So we know that first of all, as we discussed in the previous question also, that whenever there is a modulus operation, right, so mod function expression value inside the mod can be positive or negative. Ultimate value it comes out with positive, with mod it is comes out positive. So fine, so entire denominator value whatever it is, being it is non-zero, its overall value with the mod will become positive, no issue. But being the denominator, mod is appearing with the denominator term, so we should be careful that the value of the denominator should not be equal to 0, right? The value of entire denominator should not be equal to 0. Now see that since the denominator which is a quadratic, x square plus x plus 1, okay, so practically it is never equal to 0 for x as a real number. You can't find its value 0, that means putting any value of x you can't make it 0, that means it is always a non-zero quadratic expression, right, for any real value. How can you, how is it possible? First of all, if you do remember in terms of the argument based on quadratic, do you remember that I said that whenever the discriminant value of a quadratic is negative, do you remember it or not? I explained while teaching the quadratic chapter. In quadratic chapter we discussed about the nature of roots, and there I explained that whenever a quadratic expression is having its discriminant value, which is the numerical value of the expression b square minus 4ac, right? If the discriminant is negative, then the quadratic can never be satisfied by a real value of x. That means the quadratic itself can't be, the entire value of the quadratic can't be 0 at any real value of x. So that means it is always a non-zero quantity. Now then argument comes, being the non-zero quantity, will it be positive or negative? So practically it is always a positive quantity. So all those quadratic whose discriminant is a negative number, all those quadratic whose discriminant is a negative number is basically a positive quantity against any real x. You can check it in other way also, x square plus x plus 1, if we convert it something like that, 2 into x into 1 by 2 plus 1 by 4 plus 1 minus 1 by 4. That means what I am doing, I am trying to find out the minimum value of the expression, right? On doing that, I am converting x in 2ab form so that b square can be introduced here, and this entire expression in this bracket, that will be basically x plus 1 by 2 whole square plus rest of 1 minus 1 by 4 will be 3 by 4. Are you getting it or not? So this shows that x plus half whole square, that can't be negative. It can be minimum value of this x plus half whole square being 0. So when this expression is minimum 0, the entire expression's minimum value will be 3 by 4. So we can write down this expression value is always greater than equal to 3 by 4. Getting it now? X square plus x plus 1, x square plus x plus 1, that value, that expression value is minimum 3 by 4 and maximum it can be positive infinity. It can't be negative, so that's why any value of x you substitute in the either in the numerator or in the denominator. Numerator can be anything, it can be positive, it can be negative, it can be 0, but your corresponding denominator should not be 0. So yes, it can't be 0 anytime. For any value of x you substitute in the expression, it will always be more than 3 by either 3 by 4 or more than 3 by 4. So that means this, and mod of positive quantity is always positive. So that's why denominator can never be 0, and the crisis of existence of y as a function of x, that is to make y defined, the expression in x in denominator part should be a non-zero quantity. So yes, it is always non-zero, it is always positive. So all real values will be the answer of this particular question, which is the option B. That is question number 8. 8 is about y equals to under root of mod of x minus 2 divided by x plus 1. Yes, again it is like the question number 2. Question number 2 was given like this. It was under the entire expression, numerator to denominator, it was under even root. Here also it is entirely under even root, and only the numerator part is having a modulus operation, right? So again the same argument you need to make, that should be mod of x minus 2 divided by x plus 1. First of all, it can be 0. Okay. Secondly, mod of x minus 2 divided by x plus 1, it can be allowed positive, right? And the third point that is to be applied, the condition that should be applied, that is x plus 1, that should be non-zero, being it is denominator part. Is it okay? Are you getting all the points satisfying here? First of all, the expression under the even root should be 0. Second point, expression should be positive, and importantly, denominator should be non-zero. First of all, to satisfy the condition of number 1, first one, mod of x minus 2 divided by x plus 1, that means it can only be 0 when numerator is 0, that is mod x minus 2 can only be 0, and we know that mod of x is always positive. So that's why this mod of x being plus 2 can make it satisfy. So that means here x minus 2 and plus 2 both will satisfy this, right? X taking minus 2 will make it plus 2, mod of minus 2 will be plus 2, and of course mod of plus 2 will also be plus 2. If it is plus 2, x plus 2 in the denominator, then it should be x plus 2 with all of you. Okay, no issue. Let it be doing with the plus 2. Okay, rest things will be same. Okay, so far as the numerator can only be 0, so numerator can be 0 with x taking either minus 2 and plus 2. First point. Second part answer is, this is greater than 0, means I will apply the same concept again, that is I will multiply both numerator and denominator with existing denominator, which is x plus 2 after correction. So in that case, denominator will be x plus 2 whole square and numerator will become mod of x minus 2 into x plus 2, that is being positive. So since denominator is confirmly positive, it can't be negative, so by argument numerator will also be positive. So mod of x minus 2 and x plus 2 both need to be positive. Okay. So now there will be two conditions that we need to think about it. First of all, when product of two linear factor positive means both are positive or both are negative. So if I now in this case, if I further take the number 1 options, where I am saying that mod of x minus 2, that is positive, then obviously corresponding x plus 2, that 2 need to be positive. Getting me? So in this case mod x plus 2 greater than 0, that implies that x greater than minus 2. Okay. To make one factor positive, the other factor also need to be positive. So this can only be positive when mod of x will be itself greater than 2, and under which condition mod of x can be greater than 2? Can you tell me? Under which condition mod of x can be greater than 2? When x will be less than minus 2 or x will be greater than plus 2. Are you getting my point? X will be less than minus 2 or x will be greater than plus 2. What we are getting the condition, if we take x less than minus 2, we can make this positive definitely, but on taking x less than minus 2, we can't make this positive. So to satisfy, to make both the factors simultaneously positive, so the common value of x, so that this and this both will be satisfying, because once we will take x less than minus 2, so for example x equal to minus 3. So for minus of 3, mod of minus 3 can be plus 3, so 3 minus 2 is positive. But when we will put minus 3, so it is positive, it will negative, so it won't satisfy. So that's why the from this set common x, this implies that common values of x, that will be satisfying for x greater than minus 2, because x less than minus 2 will definitely satisfy this but not this. So to satisfy both of them, this saying that x greater than plus 2 and this is x greater than minus 2. So most common will be x greater than plus 2. Are you getting it? Are you getting it? X greater than minus 2 will make this positive, but again this one will not be positive for x greater than minus 2. X greater than plus 2, that will come in this range as well as in this. So x will be greater than plus 2 will be the one solution set when I am taking both positive, or the second argument will be when mod of x minus 2 is less than 0 and correspondingly x plus 2 that is also less than 0. So in this part x will be less than minus 2 to make this is negative, and when this to be negative, this also need to be satisfied, that is x mod of x less than 2. So mod of x less than 2 means x should be lying between minus 2 to plus 2. So when x lying between minus 2 to plus 2, check it, x less than x, I mean like in interval minus 2 and plus 2, for mod satisfying this, and this is saying this. So no solution can be obtained from this part. Are you getting it? Are we getting any common value of x? To make mod of x minus 2 negative, we need to choose x somewhere in between minus 2 to plus 2, and simultaneously to make x plus 2 negative, x need to be less than minus 2. So no common value of x we are getting. So that means this entire argument will only be satisfied for x greater than 2. This is the only permissible set of x satisfying this expression greater than 0. And of course x plus 2 can't be 0, means x minus 2 can't be taken. So that is the reason why to make the numerator 0 we cannot include x equal to minus 2. But yes, we can include x equal to plus 2 to make the denominator 0, numerator 0. So that means ultimate solution will be here x greater than equal to 2. This will be the solution range of this particular question. Getting me? Next one is question number 9. In question number 9 it is again log with modulus. Log of saying x square minus 4 and mod value is given x minus 1. Okay. So two conditions will be applied here, A and B. On both we have to apply the condition. First of all, that is A, which is x square minus 4, that need to be positive, and we know that this implies that x plus 2 into x minus 2, that need to be positive, because they always, log should be always defined for positive quantity. So that means product of x plus 2 and x minus 2, that should be positive. It is the breaking of x square minus 4 as a plus b into a minus b. So from this we can write down x less than minus 2 or x greater than plus 2. Okay, that can be the permissible range of x to make x square minus 4 positive, right? And relating to base, b is here mod of x plus 1, and our argument is, since b need to be positive but b can't be 1, so that means here mod of x plus 1, okay, mod of x plus 1 always positive. So we know that except x plus 1 becomes 0, otherwise x plus 1 will always be, mod of x plus 1 will be always positive. Either x plus 1 becomes positive quantity or negative quantity, its modulus value is definitely greater than 0. So that means this will be satisfied for x not equal to minus 1. If we do not consider x equal to minus 1, right, if we don't consider x equal to minus 1, otherwise it won't be 0, otherwise for any other value of x other than minus 1, it will be a non-zero quantity. So mod of x plus 1 will be always positive. Oh sorry, it is x minus 1, I am making mistakes. Okay, mod of x minus 1, so that means x can't be equal to plus 1, right? Being it is x minus 1, mod of x minus 1, we can't make it 0, otherwise it can be allowed, x minus 1 can be allowed itself as a positive or negative. So that's why we need to exclude 1, and at the same time, since mod of x minus 1, mod of x minus 1 being the base can't be equal to plus 1, right? Base can't be equal to plus 1. So that means this implies that x minus 1 can't be equal to plus minus 1. Are you getting me? We know that plus, mod of a plus 1 can be plus 1, or mod of a minus 1 can also be plus 1. So that's why this x minus 1 should not be allowed as a plus minus 1. So taking the positive sign, that means we can't make this. So that means x can't be equal to plus 2 or 0. Are you getting it? Taking x equal to 0, it will be mod of minus 1, that can be plus 1, we can't allow it. Or taking x as plus 2, it will be plus 2 minus 1 will be plus 1, and that value will also be 0. So that means we need to exclude the value of 0 and 2, making the base valid, existing base. So what are the values possible? We can allow x anything less than minus 2 or greater than plus 2. That means this, first of all, it is not including plus 2 value, not including 0, so those values are not coming in it. And secondly, if you take x equal to 2 or 0, first of all, if you take x equal to 0, so this will not be satisfied. So that's why we are going out of this argument. I mean, like in this range, we are not getting plus 2, we are not getting 0, and another value that we have to exclude, that is plus 1. Even we are not going to touch plus 1 also in this range. Are you getting me? Are you getting me? The base values, critical points which we need to exclude, we don't need to include them at all, because ultimately to satisfy both of them, this will be the answer will be then x will be less than minus 2 or x will be greater than 2. Okay, we won't take anything in between minus 2 and plus 2, and all critical values relating to base, you can see are coming in between minus 2 and plus 2. So, we are not at all going to include any value in between minus 2 and plus 2. So, that is why critical values against the base are already excluded. Could you follow my point? So, that is why answer will be x less than minus 2, x greater than plus 2. Now, the last one, that is the question number 10. Question number 10 suggests that it is y is equal to 1 divided by under root of 2x plus 3, 2x plus 3 and x minus 1, two linear factors product. So, again it is a very simple argument. Being denominator, we have already done this, that denominator under even root. So, first of all, being under even root, so it can't be negative, and secondly, being it is the denominator expression, it can't be 0 also. So, it can only be allowed positive. So, here I can write down the actual condition that should be applicable here. So, that is the product of 2x plus 3 and x minus 1, it can only be allowed positive, right? And when the product of two linear factor is positive, subject to the condition coefficient of x is positive in both. So, critical values are x equal to minus 3 by 2 here and x equal to plus 1. So, x will be simply less than minus 3 by 2 or x equal to greater than 1, isn't it? So, the simple answer will be x less than minus 3 by 2 and x greater than plus 1. So, this is the range of x as well as the solution of this question, which is the option B. So, I hope you have got answers, and wherever the doubts you had, I expect that all the doubts are cleared now.